multiples and factors, and also using prime factorizations of a number to find LCM and the highest common factor. In this topic today, there are important terms that we should explain before unpacking on the LCM and highest common factor. The first word is factors. What is a factor? A factor can be divided into a number with no remainder. Let's make an example of the statement with saying with no remainder. If we want to find the factors of 30, in other words, we want to find those numbers that can divide into 30 without leaving a remainder. The first number that can divide into 30 without leaving a remainder, let's take 2. 2 goes how many times into 30? Goes how many times into 30? It goes into 30 by 15. It means 15, there's no remainder. We can also divide 30 by 3, and then it goes how many times? 10 times. It does not leave a remainder. And we can also divide by 10, and 10 goes how many times to 30? 3 times, and it cannot give a remainder. All those numbers that cannot leave a remainder, when you divide it into 30, we call them factors. The second term is multiples. The multiples are a number are found by multiplying the number by only a natural number. Let us find the first 6 multiples of 6. The first multiples of 6 are 6, 12, 18, 24, and 30. These multiples, you multiply them by a natural number. 1 multiplied by 6 is 6. 2 multiplied by 6 is 12. 3 multiplied by 6 is 18. 3 multiplied by 4 is 24, and so on. The 1, 2, 3, and 4 are the natural numbers, which multiplies the multiples of 6. Third term that should be explained, which is very important also before we start with the LCM and highest common factor, is prime number. A prime number has only 2 factors, one and itself. An example of those prime numbers is 2, 3, 5, 7, 11, 13, and so on, because there are many prime factors, prime numbers in the numbers. The fourth also term that you need to explain, it is a composite number. A composite number is a number that has more than 2 factors. Those numbers are, let's make an example, number 8. It's a composite number. Since the factors of 8 are 1, 2, 4, and 8. There are 4 factors. There are more than 2 factors that number 8 has. The fifth term that we need to explain also is a square number. A square number a number multiplied by itself, it's a square number. Let's make an example. 25, it's a square number. Since 5 multiplied by 5 gives us 25. Now, yesterday we discussed the natural number and the whole numbers. And we said natural numbers started with 1. And 1 here, it is an universal number since it's neither a prime nor a composite number. Writing a number as a product of prime factor, of prime number. Each composite number can be written as a product of its prime factor. Let's make an example of 20. 20 is equal to 4 multiplied by 5. And that 5 and that 20 also can be 2 multiplied by 2 and multiplied by 5. And when it is written, these prime factors in the index form, it is 2 to exponent 2 multiplied by 5. Very important thing. For a large number or a bigger number, we use a 3 or a ladder method to find their product. The hint is always start with the smaller prime factor. However, in order to understand very well the prime factor, including prime numbers, we need to understand the divisibility rule. Divisibility rule is a number is divisible by 2 if the last digit is even, it's an even ending. If the number ending with 2 or even number, that number can be divisible by divided by 2. 3. If you want to see whether 3 can go to that number, you must add the sum of the digit. If the sum of the digit are divisible by 3, therefore that number is divided by 3. 4. If you want to know the number can be divisible by 4, the last 2 digits are divisible by 4. Check the last 2 digits. If they are divisible by 4, therefore that number can be divisible by 4. 5. Check the number. If the last digit is 0 or 5, in that number, it means that number is divisible by 5. 6. A number is divisible by 6 if the number is divisible by 2 and 3. If that number is divisible by 2 and 3, that means 6 can also go to that number without leaving a remainder. The last 3 digits, if we take number 8, the last 3 digits are divisible by 8. If the last 3 digits in the big number are divisible by 8, which shows to me that the number can be divisible by 8, can be divided by 8. 9. The sum of the digit is divisible by 9. If the sum of the digit, when you add them, is 9, all the numbers in that number, if you add them and you find that their sum is 9, it means that number is divisible by 9. Lastly now, number 10, the last digit must be a 0 to say that that number is divisible by 0. Now let us start and see how do we get the LCM and the highest common factor of a number. How to write a large number as the product of its prime factor. Let's make an example. Write 210 as the product of its prime number. I indicated earlier, if you have a large number, there are two methods that can be used. It's a tree method and a ladder method. The first one is the ladder method. Is the ladder method. The ladder method is when you divide, taking the first prime number, which is 2, and you divide 210 by 2, we'll get 105. And then we see 2 cannot go to 105, and then we take 3, the second prime number, and 3 goes how many times is 105? It goes into 35. And then we can see also 3 cannot go into 35. We take the next prime number, which is 5. It will go into that by 7. 7 times. Now, that was the 3 method. If the ladder method is the division method, you say 2 goes how many times into 210 is equals to 105, and also divided by 3 is goes how many times? 35, and then you take 5, and it goes how many times into 35? 7 times, and then you go to the next one again. 7 goes how many times to 7? Once. And then after that, you're writing all the prime factors of that 210. It is 2 multiplied by 3, multiplied by 5, multiplied by 7. That is how we use the 2 method to find the prime factors of a large number, which is 210. Using prime factorization to find the LCM, or the highest common factor. With small numbers, for small numbers, you can write out a list of factors or any multiples to find the LCM and the highest common factor. For example, if you want to find the highest common factor and the lowest common multiples of 24 and 18, firstly start with the factors, or you may start with the multiples depending on which term do you understand best. The factors of 24 is 1, 2, 3, 4, 5, 8, 12, and 24. And the factors of 18 is 1, 2, 3, 6, 9, and 18. We can see from the 2 factors of these 2 numbers, 1, 2, 3, 4, and 6, 8, 12, and 24. The highest in the 2 numbers is 6. Yes, we have 1 and 2, we have 3s and 4, but now the highest common factor of the 2 numbers is 6. Multiples. We can also use the multiples in the small numbers to find the LCM of the small numbers. The multiples of 24 is 24, 48, 72, 96, 120, and so on. Remember, I said earlier on, to find the multiples, you multiply the multiples of a number by a natural number. 1 multiplied by 24 is 24. 2 multiplied by 24 is 48. 3 multiplied by 24 is 72, and so on. The multiples of 8 is 18, 36, 54, 72, and 90. The same way, we multiply 18 by a natural number, which is 1 by 18 is 18, 2 by 18 is 36, sorry, and then 3 by 18 is 54, and 4 by 18 is 72, and 5 by 18 is 90. So when you check those, there is a number which is common there, which is the number is 72. And then 72 becomes the highest, the lowest common multiples of 24 and 28. Now, with the large number, for the large number and the small number together, you can also use the tree diagram or a ladder method. Use a prime factorization. For example, use the prime factorization to use the prime factors to find the highest common factor and the lowest common factor of 24 and 18. Here are the 2 methods that I spoke about. The 3 method, this is how the 3 method goes about, and the ladder method goes about, and the tree diagram of another number is that way. Then the 3 method of 24 is 2 multiplied by 12, 2 goes into 12 6 times, and 2 goes into 26 3 times. And all these numbers are the prime numbers. In other words, 24 has the 4 prime numbers, which is 2 multiplied by 2, multiplied by 2, and multiplied by 3. We can also check that if the ladder method, 2 goes how many times into 24? 12 times. 2 goes how many times into 12? 6 times. 2 goes how many times into 6? 3 times. Then we switch to the next prime number, which is 3 goes how many times into 3 once. Therefore, the prime numbers of the prime factorization of 18 is 2 multiplied by 3 multiplied by 3. And the highest common factor of 24 and 18, you take in those common numbers, which is 2 multiplied by 6, which is going to give us 2 multiplied by 3, which is going to give us 6. And for the LCM, it is 2 multiplied by 2, multiplied by 2, also multiplied by 3, multiplied by 3, which is going to give us the product as 72. We have used two methods there of those two numbers, being small numbers. You can also use, as I indicated, you can also use a tree diagram or a ladder method, and also a factors method and the multiples factors. A Venn diagram method. You can also use a Venn diagram method to find the highest common factor and the lowest common multiples. Example, if you want to find the highest common factor of 30 and 42, number one, state the product of prime factors for each number, not in the index form. Now 30 is equal to 2 by 3 and by 5, and 42, 2 by 3 and by 7. That is the prime factors of each number. Number two, write all the prime factors of each number into a Venn diagram. Now let's take 30. 30 we have 2, and the 2 and that 2 of 42, they are in the intersection. The 2 and 3, they are in the intersection. And 5 is outside the intersection. It is only left in the prime factors of 30. And also 7, it is not in the intersection of the set, and it must also be written on the prime factors of 7. This is how we use a Venn diagram to find the highest common factor and the lowest common multiples. After, because we want to find the highest common multiples, you take in those intersection numbers, factors that are found in the intersection, and then we multiply them, and then the product is 6. And that 6 is the highest common factor of 30 and 42. We can also use a Venn diagram method to find the lowest common multiples of 8 and 12. The first, as indicated, you write all the prime factors of the two numbers. They should not be in the index form. The multiples of 8, the factors of 8 is 2 multiplied by 2 and multiplied by 2. And of 12 is 2 multiplied by 2 and multiplied by 3. Now we can see there are two commons. The 2 is in 8, another 2 is in 12. Another second 2 is in 8, another 2 is in 8. Those 2s, they are common. They are supposed to be written in the intersection of the two set. And then for the 8, the only 2 is left outside the intersection. And for 12, it's only 3 which is left outside the intersection. Therefore, because we want the LCM, we have to multiply all the terms. It will be 2 multiplied by 2 multiplied by 2 multiplied by 3, which is going to give us 24. And 24 becomes our LCM of the two numbers, 8 and 12. Let's proceed again to find the LCM of 12 and 32. Here, listen very careful. Prime factors of the prime factors of a prime number are red, and the prime factors of a composite numbers are blue. You can see 12, we have prime factors being red, 2, 2, and 3. And the composite of 12 is 6, it is blue. And 32 is 4, because 4 and 8 are composite numbers because they have more than 2 factors. And then when you divide, when you go to 2 goes into 4, 2 times. Therefore, now the red are the prime factors of 4 and 8. Therefore, after we have done these 3 diagrams, you draw and make a list. In that list, you list the prime factors of 32, which is 2 multiplied by 2, multiplied by 2, multiplied by 2, multiplied by 2. There are 5 2's that have been multiplied. And then for 12 is 2 multiplied by 2 and 3. After that, you check the pair, the first pair and the second pair, and then don't have pairs for the 3 2's that are left. And also number 3 don't have a pair. But because you want the LCM, you have to take all the factors. But in that pair, we take only 1 2's, and the second pair only take 2, and then the rest we put them there, and then you multiply them all, and then the answer is 96, which means the LCM of 32 and 18 is 96. Find the highest common factor of 36 and 68. As indicated, the blue are the prime factors of the composite numbers, the blue ones, and the red ones are the prime factors of the prime numbers. After using these 3 diagrams, you draw and make a list of prime factors. 36 is 2 by 2 by 3 by 3. And 68 is 2 by 2 and 17. Now we can check the pair here and the pair here. You only take 1 from this pair, we can take 2 from this pair. And then you don't take 8 because there are no pair that are linked to the 2 3's and 17. Then you multiply the 2 2's and the answer is 4. That means the highest common factor of 68 and 36 is 4. If you're using this type of method. Thank you. I think you'll get the questions based on the lesson tomorrow, because I'm not yet finished writing them, but I'll even send them to Mr. Potgieter, and then you'll receive them, and to check whether you did understand what I said to you today. Thank you.